Okay, this is going to be fun. Good morning, everyone. I hope everyone's had their breakfast and maybe some coffee. So I'm going to be talking about JavaScript at scale. My name is Stephanie. I work as an engineering manager at Deliveroo. I joined as a senior front-end engineer in 2018, and I became the engineering manager of my team a few months ago. Before that, I also worked at ThoughtWorks. It's a software consulting company, and my time there also had a pretty strong influence in how I view software development. So what is Deliveroo? Deliveroo is an online food delivery company. We're based in London, and we operate a three-sided marketplace. So we have riders that pick up food from restaurants and deliver them to customers. And we started in 2013. There was only 2 engineers at the time. One of them is Greg Orlowski on the left. He was one of the 2 engineers. He's also was a co-founder. The guy on the right is Will Shu. He's the other co-founder, and he was the only writer for about 8 months. He delivered food every day for 5 hours. We had, I think 100 users is probably a bit of a stretch, but maybe like 100 users a month. This is a quote from Will. He said, we had 3 restaurants. One was my landlord. I lived above a restaurant on Kings Road. He was like, you can put your tablet here, but this is a really dumb idea. And this is what our website looked like. Yeah, it's great. It's a Ruby on Rails website, complete with fake grass and a little kangaroo over there. Nobody's Australian in this company. And this is what our architecture looked like in 2014. So as I mentioned, it was a Ruby on Rails website. All of the views were ERB files. It was all running on one Heroku server. There was one JavaScript file. It was not compressed. It was 1,200 to 1,500 lines long, and all of the views used this. A lot of the business logic was on the front end, so like calculating time zones, adding currency signs. This was all revalidated on the back end, so the logic was all doubled up. And the architecture looked roughly like this until 2016. And then fast forward to today, these are like the approximate numbers of, that we have. We can't talk about our actual stats, but we now have millions of users every month. Last year, Deliveroo was ranked Europe's fastest growing company with a growth rate of more than 100,000% in 3 years between 2013 and 2016, and a valuation of about $2 billion. So we went from begging 3 restaurants to come on the platform to national advertising campaigns like this one.
This is food freedom. It's freedom to get comfortable when your food's delivered. To nick a chip, or to order what you want, where you want, when you want. Deliveroo, food freedom.
Yeah. So obviously our architecture doesn't look like it did in 2016 anymore. We no longer run everything on one Heroku server. This is like a simplified version of our architecture, but it now looks something more like this. We've had an explosive growth in terms of users, which has meant that we've had to change a lot of things to deal with this amount of scale. So I'll go into more detail on this later, but we've done this with the ratio of users to engineers also exponentially increasing from roughly 50 to 1 when we first started to 20,000 to 1 and growing. So the question we always ask ourselves is, how can we do more with less? And these are some of the lessons I've learned during my time at Deliveroo. Oh, gosh. The first is backend-driven front ends. So what are backend-driven front ends? To give you a bit of context, the ratio of front-end to back-end engineers at Deliveroo is about 1 to 5. This was the same when I first joined my team, which when I first joined was the rider onboarding team. We were in the process of building Rapid, which is what we call our new rider onboarding platform if you want to become a Deliveroo rider. So it's a mobile-first web app, which my team built from scratch using React, Redux, Next.js, and TypeScript. The application, it consists of like a series of steps that applicants have to fill out, like payment details, driving license, like proof of right to work, which would be like checking documents like passports, like visas, etc. Before I came to Deliveroo, this is kind of how I would have built this application. It might be how many of you develop React applications. How many of you use React in the room? Okay, cool. Well, a fair number. How I would normally build React applications is I would perhaps build them page by page, right? So I would have a driving license intro page, so this is a driving license step that I've opened up, and maybe a driving license type page, and maybe like a driving license front. And within those pages, I would definitely like reuse different components. So maybe I would reuse like a title and some layout and inputs and intro images. But with this approach, in our app and many others, you end up having a lot of pages that look roughly the same. With backend-driven front-end development, instead of adding these page by page, we try to think of having templates instead of pages. So how does this work? So this is basically, this is our actual step component page. I've taken out the error handling there, but this is all our step component page looks like. So what it does is it takes, the backend gives us a template name, and we map this template to a variety of different template types. So we have an input template, a confirmation template, which is kind of what we called that intro page that you saw in the beginning of each step. We have a content template, which I'll come back to later, and we have a document upload template, which was the thing on the far right that you saw, where you could upload your driving license. And so if we take the example of what type of driving license do you have page, that would take an input template, right? So inside of the input template, we might have an input form that also maps to a variety of different types of inputs. So you could have a text input, a number input, a telephone input, a radio buttons, select drop-downs, checkboxes, and lists. Putting this all together, how would this work? So on the back end, if we take the example of that driving license type page, you would, in order to display that page, you do a GET request to a step ID, and that step ID in the back end would give you back a template with a name. So this is the template name. These are the keys look like this because all of our this application is translated into a lot of different languages, so these are phrase app keys. But it has a template name of input, and it has a title. And then it also has like a variety, it can give you a variety of inputs back, right? So in this case, I've said that on this page, display a radio button with, with it's required, and it has these options. So these are the values and the labels. And also, perhaps I've already been to this page before, so I also give the data of what I've pre-selected previously. And maybe that back button, I want to be able to navigate to the previous step. When you're submitting this driving license page, what we do is we use that same step ID. We make a put request to the step ID with the data of what the person has selected. Yeah, so this is awesome. So as you can see, we were able to build this application with a very small number of templates. We only had 4. And after I joined, we actually started gradually migrating towards one master content template. So you saw there that there was this content template. Because we noticed that actually we could get even more dry with our implementation, and on each of those pages, there's just a variety of things that are always displayed, like titles, headings, text, link. So actually we could get to a point where we almost had a CMS. You could just give us the backend could just give us what they wanted to display, and we could just show it. And the benefits of this are basically, first, it's really good if you have less front-end capacity than back-end in your teams. It enables you to achieve more with much less front-end developers. Secondly, like, there's an even clearer separation of concerns, like going from that one JavaScript file that served like all of our all of our views to this was like pretty awesome. So the front end, there's even an even clearer separation of concerns because the front end doesn't need to know about how an application is constructed. It just owns these various UIs or templates. There's also a smaller initial payload size on the client, which is good for performance, and it shifts complexity from the front end to the back end. Obviously, this is a pro and a con. It might not work for your team. So for example, if you have a lot more back-end developers on your team, or so this approach is not going to work for everyone. But for us, like, we got to a point where we were able to reuse the same front end for different backends. So basically, we could configure that rider onboarding app that you saw for new countries with totally different requirements. So every single country has like a very different like set of documents and order and et cetera that they need to be able to collect. We were able to do that with basically no front end development at all. And so then we could go work on other apps, like me and the other front-end developer. Like by the end of it, there was like we could go do other things. So this approach scales really well. The next lesson I learned that I think is important to scale tech companies is decentralized decision making. So as you saw, we started off with this monolith because it was the easiest, fastest way to build at the time when we only had 2 developers. Its name is Order Web. It even sounds horrible. It's not a very descriptive name. It's Order Web. And after we grew from 20 to 100 developers, building an Order Web became slower and slower. It can take up to hours to run tests and deploy. Every time there's a bug, it takes down the whole system. And there's multiple teams working on the same code base, which makes agreeing on decisions harder and harder. So like many other companies, we decided to adopt a microservices approach. So I think this is important because it reflects our organizational decisions as much as our technical ones. So this approach allows you to decentralize decision making. It makes it easier for teams to decide to be the owner of what they work on and decide how they want to work without stepping on other people's toes. It means that you don't have to make centralized decisions, right? Like you can have these teams that have, so they're teams that are cross-functional. You have front-end developers, back-end developers, data scientists. On my team now, it's half data scientists, designers, and you can work totally as your own unit, and you don't need to rely on any other teams. The services that, for example, the consumer team owns look something like this, right? So in the back end, we have various different services for the order status. These have their own databases, order history, restaurant list. As you saw in our big microservice diagram that I showed in the beginning, we have an event bus that all of these things publish to, so like other services can get a hold of them. And then we have a new, shiny new consumer web app that is not in Ruby on Rails. It is in React and Next. And how did we do this? So how did we go from monolith to microservice? So my suggestion here is that if you can figure out a way to do this incrementally, that means you don't have to pause new feature development, and you can still continue to grow, which was super important for us. Like you saw like how fast we grew in how short of a time. Like we weren't able to just like be like, hey, we don't want to work in Order Web anymore. We need to rebuild this all from scratch. So the approach that we took is something like this. So basically, when you go to deliveroo.co.uk, for example, the browser resolves this using Cloudflare, which is our DNS layer. It's a cloud DNS layer. It also provides some DDoS protection. This maps it to a Cloudflare IP address, which then uses its DNS records to determine that request should be forwarded to our routing layer. And then the routing layer actually decides if this request should go to our new app or to the old app, like Order Web. So the first thing that we migrated over to this new app was actually the About Us page, so only the About Us page at the end of 2016. So how it works is when you go to deliveroo.co.uk/about us, it takes you to the new web app. If you go to deliveroo.co.uk, it like by default, it just routes you to the old app for everything else. So the benefits of this approach are if you spin up new front ends, you don't have to configure anything in those front ends. Like all of the changes are isolated to that routing layer, all of the config. So that's great. And what that enables is for us to, sometime in the future, hopefully get to a point where we're able to have micro front ends. So what is a micro front end? So the micro front ends first came up in the ThoughtWorks Tech Radar in 2016. It basically extends the concept of microservices to the front end. So in our case, you saw that we have started splitting the back end up into multiple services. We have different front end applications for things like the rider onboarding platform that you saw that my team built, the restaurant admin site, and the consumer app that people see. But even now, our consumer app has all of these features in it, and it's starting to become a front-end monolith. So at some point, in order to decentralize decision-making even more, it would be great to get to a point where we're actually able to work in this way. So the technical benefits of micro front ends are there's incremental upgrades. So that means that, like, for example, if you're starting a new team and you want the latest version of React, you can do it. You're not tied to the version of React that the consumer web app is currently using. The code bases are really, as I said, they're really simple, very decoupled. And for example, they're independently deployed. So that means that if the checkout page goes down, for example, like, people can still browse restaurants. So I don't have a ton of time, so I'm not going to go into that much detail on this side, but basically there's a lot of integration approaches to doing this. One is server-side splitting, which is kind of similar to our approach. There's a whole load of other ways that you can integrate. You can integrate different front-end components, different front-end apps. So there are some cons, though. One is like payload size. So first of all, you're duplicating a lot of the front-end framework code. You can solve this with caching, but there is additional complexity. And then there are also infrastructure challenges. So you need to make sure you have enough automation in place to manage these front-end apps being spun up. And the bigger thing is that this means that there are even more inconsistencies possibly across front-end applications and gives you organizational challenges. So you need to know, like, is your company in a right place to handle this? And how can we decentralize decision-making but still maintain quality and consistency? One way to do this is, like, be sure that you really share knowledge across teams. We have monthly and bi-weekly front-end meetings on different topics. This is one that I ran. We also have a ton of Slack channels. We have a number of front-end focused ones. You can use them to get, like, PRs reviewed, share common patterns, or just, like, share jokes. I use this channel to actually practice this talk to find people to practice this talk to. And basically, this is great because front ends can still learn from other front ends even if they're alone on their team. So as you saw, like, sometimes you're the only front end developer on your team. But this also allows us to spot and collaborate on common problems across teams. Which brings me to my next thing, which is reward reusability. I'm very behind on time. But this is my next point, which is reward reusability. So as you saw before, like, if you've gotten to a point where you've decentralized decision-making, you have all these separate teams, you're now faced with this problem that each of the teams might be doing the same types of things over and over again. So you need to make sure that actually you invest time in creating common libraries or tools that all teams can use. But instead of mandating that everyone has to use a particular tool or approach, the less time-intensive way, and I think the more scalable way, is to, as Matt Rainey said, so he's a systems architect at Uber, he says, mandate is a tricky word. That's what you really want to do. But the more acceptable way to say this is just provide tools that are so obvious and easy to use that people wouldn't do it any other way. So don't force your teams to use common approaches, but just reward people coming up with these common approaches so that they'll build these tools that are so easy to use that everyone will use them. So basically, use tasty carrots, don't use sticks. An example of this, so this is long been a popular way to build web interfaces is using component libraries. Like, how many people here have component libraries? Oh, okay. Okay, not that many. Right, okay, so component libraries basically allow us to share React code across apps, right? So, and we have two component libraries. One is a tools component library. It's what we use for internal tools, and it's much less strict than the consumer component library. So with the consumer component library, we care a lot more about performance, for example, accessibility. We should also care about that for our internal tools, but like we're steadily catching up there. And basically, the idea is that you can import these component libraries as dependencies into your front-end app, and you can get these things out of the box. Yeah, but none of the teams are forced to use these. And for example, in the rider onboarding app that you saw, we actually didn't use, a lot of those components weren't in the consumer component library, so we didn't end up using a lot of it. But anyone can add to these libraries, and they've grown organically. So basically, I'll show you an example next of something that I added to the consumer component library when I was building the rider onboarding app. So as you're thinking about building these tools, I think you shouldn't restrict development on them. Make them open source within your company at least, but like maybe you should provide some principles on how this should be done. So for example, for adding types of components to a shared library, it's probably better to have more components that are of low complexity and high reusability, and less components of high complexity with low reusability. So an example of this is like I added this nav header to the consumer component library. It's actually, I mean, based on you can tell from the description, it's like pretty complex. In retrospect, I probably shouldn't have done that as it had complex requirements. So it's like good to just have guidelines to help guide people. Another thing that we have is this in-house CLI tool, and it makes, you can basically scaffold and run like a simple React application in less than 5 minutes. We're always looking for ways to improve these tools though. So right now there's even a proposal out to like replace this with a template repository that's like easier to use. The fourth lesson is, I'm going to use a food metaphor here because I work at Deliveroo. But basically, this is like another version of saying, like, don't reinvent the wheel unless you have to. You've probably heard this all before, but I think it's still worth repeating here because it's one of the dangers of building reusable tools. So to give you a restaurant metaphor, I don't know if you have diners in Armenia. No. Okay. Well, this is a diner. A diner is like kind of a place where, I mean, some of them can be awesome, but most of them, they like cook a ton of food. So their menus are like books, you know, there's like pages and pages of food. And like most of it's like, it's like pretty good, but it's not like great. So instead of being a diner, you should be a Kinkali place. Yeah. So yesterday I went to this Kinkali place. It's called Kinkali. It specializes in Kinkali, and the Kinkalis were really good. They were awesome. Yeah, so instead of being a diner, be this Kinkali place. Like, focus on making a few things, like, amazingly. And as I said, you've probably heard this before, but I think it's a trap that's easy to fall into. So for example, Matt Vagney, who helped build that Create Deliveroo tool that I showed you before that helps you scaffold a React app in like less than 5 minutes, and he built the consumer component library in 2017. At that time, he also created Lemon. So Lemon is our in-house, like, custom-built component library viewer. And I guess for most of you that have component libraries, I assume that you probably maybe use Storybook instead. Yeah? Okay, yeah. So Storybook is kind of like the industry standard at the moment for component viewers. It basically has a ton of features that Lemon doesn't have. And it's also super easy for new joiners to onboard on using Storybook because they can just look up, you know, there's like a ton of training and tutorials out there. So this is a proposal. Anyone can raise these at Deliveroo and get feedback on them from other engineers, and then you're kind of like free to like do whatever you want once like you've got like maybe some feedback from other engineers. But this is basically a proposal to replace Lemon with Storybook because this is like an in-house tool that only a few engineers now know how to maintain. Right, so this is my last lesson. Cool. This is my last lesson, and this follows on from the last one. So in the line of reusability, I think it's also important to automate. But I don't think you should automate everything. I think you should automate some things. And yeah, we should get to that. But so I think the question to ask is, I think the question to always ask is, like, should we automate this thing, right? So it's always worth asking to make sure that we're at least thinking about automating and saving ourselves time in the long run, because this is how you scale. You need to scale by investing in automation. But don't just automate like for the sake of it. Look at the amount of time and effort it takes to automate that thing, and if the benefits justify the time spent. So an example of something that's great to automate, this is one of my slides. I run a code review onboarding session for new joiners, and it just has some best practices on like what you should be focusing on in your PR reviews. And this comment is basically like, focus on content instead of style. These are actually my comments when I joined the writer onboarding team. It was on an old, so this was not on the app that I showed you, but it was on the admin-facing side, so the internal tools. And basically, like, we didn't have ESLint or Prettier set up on here, which would have helped avoid me having to comment on these things. So basically, style checks should be automated with tools like linters. If your project doesn't have one set up, I highly recommend this as a way to save time. It's super easy to do. Like, for example, if you're using Prettier, you can actually just, you can install it. I have VS Code plugin, which means that it runs on save. But you should make it part of your build pipelines as well. So you make sure that everyone runs it. And this is just how you configure it. I am totally out of time, but I'm going to take an extra couple minutes. Is that OK? OK, cool. Right, yeah. So I'm out of time, but I'm going to end with what I think might be my most controversial lesson. So what about integration testing? Should you automate end-to-end tests? Right, OK, so my question here again is to ask, like, is it worth automating? So most developers say that, like, end-to-end testing takes forever. I know there's end-to-end testing frameworks like Cypress, which should be a lot faster than Selenium, which I actually ThoughtWorks built, sorry. But it's normally still, like, one of the most expensive and time-consuming part of your workflows. Like, is there a faster way to achieve the same goals? So my answer to this is QAing in production. Right, so I came from ThoughtWorks. We love testing at ThoughtWorks. Like, we love it so much. So when I joined the writer onboarding team, I was super surprised. There was no integration tests at all. We had one QA who didn't know how to do any automation testing, so we only had manual tests. We didn't have time to write integration tests because, you know, we were two front-end engineers, like, building everything for all the countries, like 13 countries. We still had a ton of unit tests, so I'm not saying don't test. But we didn't have integration tests. So instead, what we do is we test in production. That means that we QA and find bugs by using monitoring in production. And monitoring in production is something that you need regardless. Like, no matter how many tests you have, you should monitor in production. And in our case, replacing these really expensive automated tests with monitoring allows us to move faster. So I'm aware not all organizations are able to do this. We have really fast feedback loops and the scale to let us know immediately if we've broken something in production. Like, people will get paged immediately if anything goes wrong. And we have really robust CI/CD pipelines, so we can release fixes and, like, revert changes, roll back, like, basically immediately. It's important to remember, though, like, in terms of scale, like, I was on the writer onboarding team at the time. It only gets traffic when applicants want to become writers, so it has users in the thousands, like, not the millions, and we were still able to do this. So each organization has to find its own balance between, like, speed and making sure that things work before releasing to production. So for example, if you are a company like NASA, you probably don't want to test in production. Like, there's super high stakes. Something goes wrong, potentially fatal, very expensive feedback loop. So you need to be as sure as possible that things work before you, like, launch your rocket ship. But most companies lie, like, somewhere in between the scale, right? So yeah, I'm basically out of time, but like how you would do this is you would, if you want to do this in your own company, and this is probably good to set up in production either way, is just set up really robust dashboards and alerting. Make sure that you're monitoring business metrics in addition to things like CPU load, memory usage, block message queues, et cetera. So the most important thing for us is actually these business metrics. So like in the case of the team that I was on, the Rider Onboarding app, we would monitor, for example, the number of steps committed. So like, are steps still being committed? Like, are people able to still progress through the app? Are they able to become riders? Logging is super important, and then you should just keep improving this. So every time we have production outages, we have a post-mortem, and then we will add like more and more dashboards and monitoring. So this is an example of what our dashboards look like. This is from a production incident. So I went to like our, we have a production incident like Slack channel, and this is one of the dashboards that they posted. So this is basically, the green line is our orders at that time, and the other lines is like historically what our orders would look like maybe say a week ago or 2 weeks ago at the same time of day. Yeah, so you can see here like something's gone wrong. Someone got paged, they fixed it immediately. Yeah, so that's it. Thank you for the extra time. Just a recap of all the tips, like in order to do front-end development or any development at scale, you should ask yourself, how can we keep doing more with less? And these are some of the lessons that I spoke about. This is just my thank you slide. Yeah.